Hello friends, welcome back to one more interesting session that we are going to do today. It is about something called sealed secrets. As you all know, we use Kubernetes secrets to encrypt sensitive information, uh, rather encode sensitive information. The reason being, when you use Kubernetes secrets, the sensitive data in the secret is obfuscated by using a base 64 encoding, which is not sufficient because you can very easily decode a base 64 encoded secret. So we want to learn and implement uh, something more intricate called sealed secrets that will help us encrypt the secret and store it in Kubernetes. And also, once you encrypt it, it creates a file called something called sealsecret.yaml file that you can that is an encrypted format of the secret that you can store in Git. So for any workflows where you are using CI/CD platforms to use Git and check out the code, you cannot just put it in a base 64 encoded format. You need to use something called seal secret, which is a best practice where you can protect your seal secrets, because once your secrets are available to the other people, uh, I mean, they might be insiders to your enterprise, but you never know. It's a best practice to be able to keep it in a encrypted format and then store in Git. So the sole purpose of seal secrets is to store it in a encrypted format in your Git repository. So even to a public repository. So it can be decrypted only by a controller running in Kubernetes cluster, and nobody else is able to obtain the original secret from the sealed secret. So there is a concept of something called a secret controller that Kubernetes has made available for us. So once you install this sealed secret controller on our EKS cluster, it is responsible for encrypting it. It has a certificate of its own. It will search for the certificate for the public, and with the public and private key, it has its own certificate that it uses to encrypt the secret and store it in the EKS cluster. If the certificate is already not available on your cluster, it will create one newly. But the key again is you need to be able to provide the right policies or roles for the cluster in order to for the controller to do its job properly. So let's go ahead with no further delay to see how we can implement sealed secrets in our simple EKS cluster and Spring Boot application. So if you look at my Spring Boot application, as you know earlier, we have something called application.properties where I have introduced two fields which are username and password. So it could be any values. So as you can see, I am using the secrets to be passed as environmental variables here. So this will override this the so but these environmental values are directly used in the security configuration. So if you see, the username and password are passed as environmental variables. So whatever you see in application.properties will be overwritten by our Kubernetes Helm environmental variables, and then the application will use it. So how will you know that? So here I am using John1 and pass1. So instead of that, I will be overriding it with different username and password that will be used and passed down as an environment variable and will be used by my security configuration. So let's go ahead and see how we can do it. This is my previous uh, application, so I'm not going to details of how you build the Docker image and upload it, and then you build a Kubernetes cluster and put it in the cluster and install it using Helm install. That is already been discussed. So for purpose of this particular session, we are focusing solely on kubectl. So there are few reference websites from AWS, so you can refer those. So for now, what we would do is we need to install a plugin called kubectl. So you can install it using this command. I have already installed it. It's simple and straightforward. In any case it gets corrupted, you can overwrite it with this particular command called brew link override kubeseal. And there is some more optional thing, you won't need it, but in case you want to use some certificate or from your own platform, you can do other things as well. So for now I'm using the default certificate that will be provided by the controller. So one more important thing is, when you create the role for Kate and you apply it to the user or the EKS cluster, you need to give a policy that will help the controller access the EC2s or where the nodes are deployed and be able to override the controller, override the secrets and all that. So for that, this is the particular policy that you need to add, and once it is done, you need to apply the controller, the seal secret controller, it's from Bitnami Labs, so on your EKS cluster. So how could you do it? So let me show how. So what happens when you apply the controller? So I have already done it earlier, so let's hope it goes ahead smoothly. So we have applied the controller version 0.19.2. Now we're going to get the parts and see what is happening. So there is a new pod created called Sealed-Secrets controller. Okay, so let's go ahead and grab the logs. So as you can see, there is a secret certificate as well that is being printed out. So it has created its own encrypting certificate with the public and private key. So the other thing that you could do is, you could that other thing that we need to do is generate a sealed secret from the secret.yaml file. So what is there in my secret.yaml file? So I have a simple uh, secret value that I have already encoded in base64 format, or you could use the YAML tilde and base64 command with your visible secret and create this file. So once you create this file, so all these formats of IMLs, everything will be available on the AWS site that I gave you for reference earlier. So I don't need to go into detail of that. So once you have this file, you execute this particular command where you are using the seal secret, and using the controller you are encrypting it into a file called sealsecret.yaml file. So let's go ahead and see what it created. So Seal Secret has a encrypted format. So it would say API version is from bitnami.com and the kind is Seal Secret. So when you look at your cluster secrets, the moment you see Seal Secret, you need to understand that this is a Seal Secret and not a normal secret. And then it is under the namespace called name-secret. Again, this we have already defined in the metadata. So that's what we have right now. And we need to apply it to our cluster. So I have already applied it. So you can go ahead and execute this command to apply the secret. So, and you could use manually, you could print it out here, or you could use the console, AWS console, to look at what is being created. I think it will print the base64 format. It will unencrypt it and print it. And there is something else called KMS encryption on top of this envelope encryption. Once I try it, I will make it available as a YouTube video as well. So keep looking out, friends, for that particular session as well. It's going to be very interesting. So once you do that, you can upgrade your application. I'm not going to do it now, but you can do Helm upgrade because I have already deployed my application instead of Helm install. So once, this is the basic stuff that you would do with any EKS cluster, and then once the application is up and running, what you will have you need to access your application and see if your application is being made available. So if you look at the logs, right, so basically you can verify it if the application is printing your secret or not, you are able to access it or not. So in my case, I'm just directly verifying using the website, okay, using my cluster port, okay, node port, sorry. So it is able to create my PKCE code and provide it to me. So that itself is a proof that my application is working fine. So that's about it for today's session, friends. So this is the way you can create a sealed secret and implement it for your enterprise. Thank you so much for your support. Keep coming back for new videos and support me. Subscribe to my channel. Thank you so much.